In this lesson, we're going to look more in depth at compound events and calculating compound probability. Remember, a compound event is the probability of two or more simple events. And some examples of compound events that we have looked at is when rolling a dice, or two dice, or drawing a card, or spinning a spinner. So just like with regular probability, only you have more than one event happening. So what we want to do is actually calculate this compound probability. Compound probability is the probability of a compound event. As a single event, the probability of a compound event is the ratio of the number of favorable outcomes to the total number of outcomes. So we're still referring to ratios. So you still want to be writing this as a ratio. So let's look at one way when you have a tree diagram. So with a tree diagram, we're going to roll a die and we're going to toss a coin. So when we roll the dice, what could happen is the dice could land on the number 1, it could land on the number 2, 3, 4, 5, and 6. Then, when we flip the coin, for each side that the dice can land on, that coin can land on either heads or tails. And then writing all of your possibilities in your sample space, you could roll a 1 and it land on heads, roll a 1 and it land on tails, or a 2 and it land on heads, or a 2 and it land on tails. You could roll a 3 and land on heads, a 3 and it land on tails, a 4 and it land on heads, or a 4 and it land on tails, a 5 that lands on heads, or a 5 that lands on tails, or a 6 and it land on heads, or a 6 and it land on tails. So those are all of your possible outcomes. So let's look at calculating some specific probabilities. A wants us to calculate the probability that it lands on heads. So taking a look at our sample space and all of the probabilities, I have 1, 2, 3, 4, 5, 6 outcomes that land on heads. So 6 out of my total of 12 outcomes is my probability that it will land on heads, which simplifies to 1/2. And remember, we can write that as a decimal and a percent. What's the probability that we'll roll an even number? So if we take a look at our sample space, we have 1, 2, 3, 4, 5, 6 outcomes that include an even number. So 6 out of a total of 12, which simplifies to 1/2. Go ahead and highlight C, D, and E. And let's look at an example with a spinner. So with a spinner, we're going to spin it to the left twice. So the first time we spin it, it can land on A, B, it can land on the number 1 or the number 2. All of our sections on the spinner. If it lands on A, I could spin it again and it could land on A again, could land on B, 1, or 2. If it landed on B, it could land on A the second time, or B, or 1, or 2. If it lands on 1 the first time, It could land on A the second, or B, or 1, or 2 the second time. If it landed on 2 the first time, it could land on A the second time, or B, or 1, or 2. Now go ahead and write down all of your possible outcomes in the sample space. So that's all of our possible outcomes. So there's 16 possible outcomes. So to look at specific probabilities, the first one is the probability that you get a letter both times. So I could get AA, AB, BA, BB, which is a total of 4 times. So 4 out of the 16 total, which simplifies to 1/4. And then again, we can write that as a decimal, 0.25, and a percent, 25%. Go ahead and highlight B, C, D, and E. And let's take a look at our second method. Our second method is going to be using when we're going to be multiplying the probabilities. And you want the probability of 2 independent events can be found by multiplying the probability of the first event by the probability of the second event. So your 2 events have to be independent of each other. That means one doesn't depend on the other. So taking a look at the spinner is spun twice. Find each probability, A, B, and C on the left. So you can see when we spin the spinner, it can land on a letter or a shaded region. So A says to find the probability that you land on W both times. So when you spin it the first time and you land on W, that's 1 out of 6, 1 out of 5, because you have one section out of your 5 total that has a W. Times, if you spin it again and it lands on W again, it's still a 1 out of 5 probability. So I can multiply that. 1 times 1 is 1 and 5 times 5 is 25. So my probability of spinning a W both times is 1 out of 25. Let's look at another one. The probability of spinning an E, and then on the second spin, it landing on a shaded region. So the probability of spinning an E is 2 out of the 5 sections, because you have 2 sections that have an E out of your 5 total sections, times the probability that it's going to land on a shaded region. There's 3 out of the 5 sections that are shaded. So then we can multiply. 2 times 3 is 6, and 5 times 5 is 25. So the probability that the first time it will land on E and the second time it'll land on a shaded region is 6 out of 25. Go ahead and highlight C. Number 4. There are 4 red, 8 blue, 2 green, and 6 yellow paper clips in a jar. A paper clip is drawn, replaced, and then another paper clip is drawn. Find each probability. It's very important here that it tells you it's replaced. Sometimes you can have examples where it's not replaced, and that'll change your probability completely. But for now, we're going to be looking at ones that are replaced. So we want to first find the probability that you're going to pull out a green and then a blue. So the probability that you'll pull out a green is 2 out of 20 because there are 2 green paper clips out of a total of 20 paper clips. That can simplify to 1/10. To make it easier, let's keep it like that for now. We can simplify it at the end. So the probability of pulling out a green one is 2 out of 20 times probability of pulling out a blue one. There's 8 blue paper clips out of still a total of 20. So 2 times 8 is 16, and 20 times 20 is 400. And then we can simplify this down. It simplifies all the way down to 1 out of 25. So there's a 1 out of 25 chance that you'll pull out a green paper clip and then a blue paper clip. B wants to find the probability that both times you don't pull out a red one. So if you're not pulling out a red paper clip, you're pulling out either a blue, green, or yellow. Blue, green, and yellow all together are 16 out of the 20. Times the second time you're not going to pull out a red, so it's again 16 out of 20. So for this one, it might be easier to go ahead and simplify before you multiply. 16 out of 20 is going to simplify to 4/5 times 4/5, which is 16 out of 25. So the probability that both times you won't pull out a red is 16 out of 25. Go ahead and highlight part C. And then highlight 5 and 6 and complete all 3 parts for each one.